Take our lead. Let's help you make your mark. Our goal is your satisfaction. Let us show you the way.
Both CO2 and H2O have two polar bonds. However, the dipoles in the linear CO2 molecule cancel each other out, meaning that the CO2 molecule is nonpolar. The polar bonds in the bent H2O molecule result in a net dipole moment, so H2O is polar.
Take our lead.
So CO is polar as the polarity of the carbon-oxygen bond is unbalanced and the distribution of partial charge on the bond affects the whole molecule, giving the whole molecule a dipole moment. But CO2 is a linear molecule and the partial dipoles of the two bonds are in exactly opposite directions.
Make your mark. Take our lead.
Carbon dioxide is nonpolar because of the symmetry of its bonding. The electronegativity difference between carbon and oxygen is 1.0, which makes the bonds polar. However, the two polar bonds are at 180 degrees to each other, so the dipoles cancel out.
Make your mark. Take our lead.
Polar covalent bond. HBr is a polar covalent bond. Notice that the electrons spend more time with Br. This end of the molecule is partially negative. Because the electrons don't spend much time around hydrogen, this end is partially negative.
Take our lead.
CO2 is a linear molecule, so the resultant dipole moment is zero since the individual dipole moments of CO bond cancel each other. Whereas, SO2 is an angular molecule due to which it has a net dipole moment. Hence SO is polar and CO is nonpolar.
Take our lead.
If the arrangement is symmetrical and the arrows are of equal length, the molecule is nonpolar. If the arrows are of different lengths, and if they do not balance each other, the molecule is polar. If the arrangement is asymmetrical, the molecule is polar.
Make your mark. Take our lead.
A molecule like CO2 may be composed of two dipoles, but it has no dipole moment. When molecules have an even charge distribution and no dipole moment, then they are nonpolar molecules. CO2 is a linear molecule, so our dipoles are symmetrical. The dipoles are equal in magnitude but point in opposite directions.
Thank you for watching. Please subscribe and hit the bell notification.